Another application is a piece of cardboard is twice as long as it is wide. It is to be made into an open top box by removing a 2-inch square from each corner and folding up the sides. So we have a piece of cardboard that is a rectangular piece. We know that it is twice as long as it is wide. So if we let x be our width, the length is twice that, or 2 times x. So from this piece of cardboard, we're going to make a box, and we're going to do that by removing a 2-inch square from each of the corners. And so we know that the length and width of each of those pieces cut out is 2 inches. And so you can visualize this, right? If we cut that out and then we fold up what's left along these dotted lines, we can get a box from that. So really what we're going to have we'll have something like this that then we fold up. And we need to determine a function that represents the volume of the box in terms of x, and then to determine what dimensions will yield a volume of 320 cubic inches. So the volume, if you remember, of a box is length times width times height. So we have to figure out those dimensions of this new piece of cardboard, right? Because now those are the things that we're folding up to get the length, width, and height of the box. So we originally had a piece that was x inches wide, but we removed 2 inches from each of the sides, right? The 2 inches has been cut out from each of the sides. And so we cut out 2 there and 2 there. So we've actually cut out 4 inches total from the length of that. So now we have this remaining piece is x minus 4. Our original length was 2x, but again we cut out 2 inches from each of the sides. So we've reduced that by a total of 4 inches. So what remains is 2x minus 4. And then the height of the box is what stands up, right? When we fold that up, that piece stands up. Well, this is a piece that's standing up. It was 2 inches laying flat, so when it stands up, it's still 2 inches. So the volume can actually be modeled by the length is 2x minus 4 times the width is x minus 4 times our height, which is 2. And this problem says to find out what dimensions will yield a volume of 320 cubic inches. So there we know the volume. We need to figure out what the dimensions are, so that is we need to solve for x. Our equation in that case is setting the volume function equal to 320. We can simplify that first by dividing by that coefficient of 2. We get 2x minus 4 times x minus 4 is equal to 160. Now we need to multiply this out and put it in the standard form of a quadratic equation. We get 2x squared minus 8x minus 4x plus 16 equals 160. So this becomes 2x squared minus 12x. Now we can subtract 160 from each side. And when we do that and combine like terms, we get minus 144 equals 0. You could solve this at this point by trying to factor or use the quadratic formula. One thing I would observe is that there's a common factor of 2, and if I divide out by 2, I get the equation x squared minus 6x minus 72 equals 0. And then I can probably solve that by factoring. If not, I could use the quadratic formula or completing the square. But I need to find the factors of 72 whose difference is 6. And those do exist. That is 12 and 6. So I would know that the larger factor needs to be negative. So we have x minus 12 times x plus 6 equals 0. So therefore x minus 12 is equal to 0, or x plus 6 is equal to 0. So x is 12 or negative 6. And in this case, because x represents the dimension of a box, we cannot have a negative value, so we're going to discard that. So x is 12. Now it asks us to find what dimensions of the box will yield a volume of 320 cubic inches. So x is our original length or width of the cardboard is 12. And so the length of that is 2 times 12 or 24. So the dimensions of the box so we know that the height of the box is 2 inches. The length of the box was 2 times the 12 minus 4, right, or 24 minus 4, which is 20 inches. And then the width of the box is going to be 12 minus 4, or 8 inches. So the box is really a 20 by 8 by 2 inch box. We could have also been asked to figure out what value of x will give us the maximum volume. And in doing that, we would have to multiply this expression out to get a quadratic function and then find the vertex of that. So just keep in mind the different types of questions that you can be asked. But when you're trying to find a specific value of x that yields a certain value, you're always going to set that equation up and solve for the value of x.